I'm going to make the claim that you should never deal with time zones manually. But as well as that, I'll tell you everything you need to know about polars and time zones. Let's get this started. So first of all, why you should never ever deal with time zones manually. I'll try to make a convincing case. Pardon? I heard something but didn't really make out what. Okay, I'll assume that was okay. And we'll continue. Where were we? Right, going to make the case for why you should never deal with time zones by hand and what you should do instead, that is to say, use software like polars. In order to be able to use polars for time zones, I'll then give a quick crash course on polars and tell you the basics of what you need to know to be able to use it for date times and time zones. Then finally, we'll get to the real meat of it. We'll talk about polars and time zones. And finally, we've got some minutes split between an engaging Q&A and an awkward silence. It's entirely up to you how long we make X in this equation. Every now and then, I'll just go from sharing full screen to checking whether anyone's written in the chat. I'd like this to be somewhat interactive, so if you have questions, you don't need to wait until the end. Feel free to make comments, and I'll try to address them. Right, why should you never deal with time zones manually? So first of all, maybe let's have a show of hands. Is anyone here a flat earther? Do we have any flat earthers in the house today? Not all at once. I think I saw a reaction, but oh yeah, wow, got a thumbs up. Nope. Okay, that's the reaction I was hoping for. I'm not a flat earther myself. Not a flat earther, just re-emphasizing that in case anyone takes this video out of context and misquotes me. But I do see the appeal. Like in particular, when it comes to time zones, it would all be a lot simpler if the Earth was flat. So the days would always have 24 hours. December the 30th would always come after December the 29th, and scheduling cross-continent meetings would not be absolutely migraine-inducing. Anyone who tried this out will know exactly what I'm talking about. So I'm based in the UK, so let's introduce the topic of daylight savings time in the most British way possible. That is to say, with a pub quiz. So suppose you're in Eindhoven, which is in the Netherlands, and it's midnight on the 26th of March, 2023. You then wait 4 hours. What time does your watch show? Please write your answer here in the chat. Okay, got a thumbs up from Ian. Hi, Ian. So Aditya says 27th of March, 4 a.m. Okay, so it's you're starting on the 26th of March at midnight, and we're adding 4 hours. So 27th of March would be quite a lot longer. Arthur says 5 a.m. That's absolutely correct. That's the first correct answer. Oh, hi, Sheng. Sheng also correctly says 5 a.m. Yeah, it is indeed 5 a.m. Okay. I've seen a couple of people write 27th of March, so note that I wrote plus 4 hours, not plus 24 hours. And why is the answer 5 a.m. and not 4 a.m. as you might have expected? And that's because of a very silly thing called daylight savings time. Let's learn about this thing. So there's two components to it. The first is in October, where we do something very silly. We are having such a good time in the night that we don't want the party to end. So when it gets to the end of 2 a.m., we just go back an hour and repeat 2 a.m. until 3 a.m. So some date times end up being ambiguous. If it's 1:45 and you're waiting for somebody and they tell you they'll be there at 2:15, you have to know there's no guarantee that they'll be there in half an hour. They might mean 1.5 hours. In March, we then do the complete opposite thing. So we're very keen to get up and go to work. So we just skip an hour completely between 2 a.m. and 3 a.m. So if somebody tells you of an amazing thing that they did at 2:30 a.m. on the 26th of March, 2023 in Amsterdam, you have to know they're making it up. This is one way of calling your friends out on their bullshit stories. And you might be thinking, this isn't actually that bad. Like, sure, there's some weirdness, but at least it's consistent year on year. Like, as long as you've got down some set of rules for when you go back an hour and when you go forwards an hour, how difficult can it be? Well, pretty difficult as it turns out. Let's have a look at what happened just in 2023. So in Amsterdam, on the 26th of March, they skipped an hour. Meanwhile, in the US, they also skipped an hour, but 2 weeks earlier, on the 12th of March. Most people in Asia and in Africa, I presume they regard daylight savings time as colonialist bullshit, so they don't skip any hours at all. But not everywhere. In Morocco, they actually repeat an hour, but not at the same time as when the US and Europe skip an hour. They do it in the week in between, on the 19th of March. And then, as if this wasn't confusing enough, in Australia, on the 1st of April, in the Lord Howe time zone, which is one of Australia's time zones, yes, Australia has more than one time zone, they move the clock, they repeat an hour, except not the whole hour, just 30 minutes. And if I've not convinced you that this is virtually impossible to get right doing it by hand, well, you might be, because you might still be thinking, okay, it changes from country to country, but I can just have a list of what each country does, and then I can map them all together. I can figure it out. Well, it's not even consistent within countries. So in Samoa, in the Pacific, they once were so keen to celebrate New Year's Eve that they switched straight from the 29th of December to the 31st of December. If the 30th of December was your anniversary, then tough luck. It went from nearly midnight on the 29th of December to midnight on the 31st of December because they wanted to switch time zone. They went from a -10 UTC offset to a +14 UTC offset. So don't expect consistency, and I'd like to think that this proves that you should never ever deal with time zones manually, QED. You don't want to forget about DST, countries doing DST at different times, if at all, or countries changing their time zones. Right, what should you do instead? You should use polars or some other software that deals with time zones. That's my claim for today. So before we get into the super first polars crash course, let's take a look at the chat. Let's see if there's anything we should respond to. Clocks jump in March. All right, my watch shows 4. My watch is analog. Nice one, Jessica. Australia, just playing April Fool's prank on everyone. Lol, yeah. All right, no questions. So yeah, let's go straight into this polars crash course. Anyone here familiar with polars? If yes, then I'd like to think that it'll still show you something new, a new way of thinking of certain things. And if not, well, it's really just intended as a basic introduction. So let's get this started. So Dataframe is the fundamental object we're going to be using within polars. It's just a collection of columns, each one of which has some values which should all be of the same data type. And you can manipulate them using expressions. Wait a second, what's an expression? An expression, you can think of it as a lazy column, or slightly more formally as a function from a data frame to a series. So if I made a function like given a value x, double it, then what's the value of this function? You don't know. Like, it doesn't have a value until you give it an input. And similarly, polars expressions, they don't actually have values until you give them a data frame. So you can create an expression like pl.call a times 2.alias b, and this will only take effect once you put it inside a data frame context. Most people, I think, don't think of expressions as functions. They just kind of use them and then develop an intuition for what they do. For example, if we start with a beautiful data frame like this one, which contains one column A with values 1, 1, and 2, and then we use the with columns function, we can create a new column called B, which is just column A, but doubled. We can also use inequality comparisons within expressions and create a Boolean mask. And then we can use a Boolean mask to only keep certain rows by using the dataframe.filter function. Right, good stuff, but I know you're all very keen to go back to talking about time zones, so let's do that. But first, we need to talk about data types, and I'd like a bit more audience interaction here. going to tell you about what data types Polars supports. And what I'd like you to do is, when I read out your favorite data type, either comment here in the chat or put some emoji reaction. So first of all, let's hear it for the numeric data types. Woo! Yeah, this part works better with a live audience. Okay, got a yay from Ian, and I'm seeing some hearts, but can't see from who. Presumably we've got lots of data scientists here in the chat today. All right, Boolean. Okay, got a couple of hearts. Was wondering if I would get complete silence for that one, if the reaction was itself going to be Boolean, but no. String. Okay, a single heart. I guess we don't have that many NLP data scientists in the chat today. What about categorical? Yeah, maybe if I'd said it with more enthusiasm. Nested data types. Let's go absolutely bananas for this one. I've seen a talk on YouTube where somebody says that the primary motivation for using polars is because of nested data types. They are super powerful, the list one in particular. If anyone's doing advent of code, then the list data type can make some of the solutions pretty nifty. And then finally, my absolute favorite one, the temporal data types, mainly because you can put time zones on them, and I have a niche interest in time zones. Let's talk about them. Time zones aren't the only thing that you can put on date times. They have two components, the time unit and time zone. Why do we need both? Let's, okay, just going to get back to the chat. Unless you're in Pandas for the last 20 years. Okay, I can't remember, though, what I said when that comment was posted, so I'm not totally sure how to respond to it. Anyway, so we've got two components here to a date time, which are the time unit and a time zone. Oh, right. Yeah, Ian says that was for strings in Pandas, which are slow. Yes, they are slow, but I'll teach you a trick. If you install PyArrow and then in Polars, instead of using strings, you use string open square bracket PyArrow closed square bracket, you'd get PyArrow strings, which are way better. Aha, see my talk tomorrow. Yeah, go to Ian's talk tomorrow. There's quite a few talks here with Pandas 2 and Polars and things. Seems like a popular topic. Right, so as we were saying, date times got two components, time unit and time zone. Time unit is what's the smallest amount of time that your data type can represent. And time zone, it can either be none or something from the time zone database. So none of these ambiguous abbreviations. Use a proper time zone from the time zone database, like Europe/London or Africa/Morocco, or my favorite, Asia/Kathmandu. We'll see later why that's my favorite. Why do we need a time unit? Let's take a step back and remember how date times are represented by computers. They're represented as the amount of time since the 1st of January 1970 in Universal Coordinated Time. And just to prove to you that I'm not lying, let's look at a quick example. Let's make a data frame with the 30th of November 2023 at noon, and then look at the underlying physical representation of that column. We see this very large, unpronounceable number, but if we take that number of microseconds and add them to the 1st of January 1970, we do indeed recover our original date time. So there you go, I did not lie, QED. Why do we need a time zone? Well, time zones actually change the underlying integers, because the integer that backs the date time is the amount of time since the 1st of January 1970 in Universal Coordinated Time. So if you set a time zone, it might actually change that underlying integer representation. Got a little example here to, again, prove to you that I'm not lying. And if you compare the integers backing a time in UTC and a time in Europe, you'll see that the difference is the number of microseconds in 1 hour. Right, sorry, a glass of water. Right. And now for the exciting part of the talk, polars and time zones. But first, let's catch up with chat. Nothing to catch up on, fantastic. Let's go straight into the exciting stuff, polars and time zones. So first of all, I'd like to quote the Zen of Python, which says that namespaces are one honking great idea. Yeah, I figured that quoting the Zen of Python at PyData Global would be okay. When I quoted it at an R conference last week, it didn't get the same reaction. Yeah, I'm joking, of course. I didn't go to an R conference. In Polar's, namespaces are used to group together similar functionality. So if you start typing an expression and then type .dt, you'll get the functions which are available for temporal data types. If you then continue scrolling through, after a while, you might find my favorite function, replace time zone. Let's take a quick look at what that does. I just wanted to show you this autocomplete because Polars has excellent type annotations. So if you let your code editor help you, it will really make the experience of coding in Polars a lot more pleasurable than it already is. Let's take an example. Let's start on the 30th of November in Europe. Let's then localize that to UTC. Sorry, not localize. Let's then replace the time zone with UTC and then replace the time zone with Asia/Kathmandu. And you'll see that the local time stays the same, but the time zone is changing. You might, though, be interested in asking a similar related question, which is, if we start with some local date times in Europe/Amsterdam, then what time would those represent, but in different places of the world? So if it's midnight in Europe, then what time is it on the same day, but in Nepal? And the answer is 4:45 a.m. Yeah, that's why Asia/Kathmandu is my favorite time zone. They are 5 hours and 45 minutes ahead of UTC. I think the motivation was such that when the sun was at its highest place, it would be above so when the sun was at its highest place, they wanted it to be directly on top of Mount Kilimanjaro, but at some time of the year. And I wonder what they'll do when tectonic shift means that's no longer true. But by then, you'll all be using Polars to deal with time zones for you, so you won't need to worry about it. So when should you use replace time zone, and when should you use convert time zone? Convert time zone answers questions like, what time is it now, but in Nepal? Whereas replace time zone answers questions like, what if it was this time of day, but in Nepal? Right, we've got okay, just a smiley here in the chat, no questions to answer, so let's continue. Let's go back to the pub quiz question I asked you earlier. So if it's the 26th of March in Eindhoven, which is in the Netherlands, it's midnight, 26th of March, 2023, what time is it 4 hours later? And the answer is use Polars. So let's see how you could do that. You're going to want to use a method called .dt.offsetBy. OffsetBy can take different kinds of durations. We've got calendar durations like day, week, month, and so on, and fixed durations like hour, minute, second. So here we'll want to use 4 hours. So we'll just write .dt.offsetBy 4h. And you'll see that indeed we do get the correct answer, which several people gave earlier during the first pub quiz, which was 5 a.m. But now we got the same answer with Polars, so we're happy. I just want to include a word of caution, which is that you might naively be thinking that 1D and 24H are exactly the same thing, and this is where we come to the difference between a calendar duration and a fixed duration. So 24 hours, that literally means 24 hours. It's unambiguous, 24 hours. Whereas 1D means one calendar day. So it's same time, but on the next day. If we start on the 29th of October, 2023 in Amsterdam, and we add 1 day, we get to the 30th of October. Whereas if we add 24 hours, we get to 11 p.m. on the same day, because that's when they moved the clocks back. So use whichever one is more appropriate for your situation. I'd be willing to bet that most of the time what you really want is one calendar day rather than 24 hours, but it's good to be aware of the difference. Now, whenever I give a talk about time zones, there's always some smarty pants who tells me that we don't need time zones, we can just do everything in UTC. So let's dispel that. Suppose that we've got some date times in a European time zone and some sales for each hour. And our boss asks us, how many sales did we make in total each day? So if we were to just look at this, we would see, okay, on the 29th of November, looks like we've got 1, 2, 3, 4, 5 sales. And on the 30th of November, we've got 1 sale. So we give them that answer correctly. However, if we tried to first convert to UTC, then the date boundaries would have shifted. So on the 28th of November, we would have had 1 sale, 29th of November, 4 sales, and 30th of November, 1 sale. If our boss had asked us why we'd reported that there was 1 sale on a date that they didn't even give us data for, and we reply, well, somebody on Reddit told me to convert to UTC, we won't seem so smart. The other issue with converting to UTC is that in UTC, days always have 24 hours, but we've seen that in your local time zone, a day might have 25 hours, 23 hours, or if you're in Australia, 24 and a half hours, or 23 and a half. All of the examples I've shown you so far, they've assumed that you had a data frame which already had some date times in it. But as we all know, the world runs on CSVs which don't preserve data types. So how do we read data from a CSV into polars, especially if it's time zone aware? Now, a secret tip I'd like to show you is to use the argument try parse dates. If your date times are stored in a common format, then polars will automatically infer it for you and parse your data as you've requested as a date time. This is more efficient than first reading a CSV with strings and then later converting. If your string values contain UTC offsets, then what polars does is it converts everything to UTC, like Arrow does, PyArrow at least. So in this example, we've got some offsets like UTC plus 2, UTC plus 1, and so on. But when polars passes it, it doesn't preserve them. It converts everything to UTC. If you know that your date strings correspond to some local time zone, then it's up to you to set it as one of the D types. So we could set here date time having a D type of pl.dtime, microseconds, and Europe/Amsterdam time zone. And then we'll get what look like some local date times, each at midnight in Amsterdam. And you might be wondering, why can't polars do this for you? And the answer is, it just doesn't know. Let's have another pub quiz. Suppose it's the 29th of October 2023 at midnight, 2 hours ahead of UTC. 24 hours later, what time is it? And I'll spoil the answer here for you. It's you don't know. So if you're in Eindhoven, it would be 11 p.m. on the same day. But if you are in Botswana, then it would be the 30th of October on the next day. So polars isn't going to guess for you where you are. It's up to you to set the time zone that your date strings correspond to. So in conclusion, what have we talked about today? We've talked about how you should never ever deal with time zones manually, because there's just too much complexity around daylight savings time, time zone changes, and cross-country comparisons. We then did a polars crash course, learned a bit how to work with date times and time zones, and then finally we talked about time zones in polars. We learned about the difference between 1D, which is 1 calendar day, and 24H, which is 24 hours. We then looked at the difference between replace time zone and convert time zone for changing between time zones and when you would use one rather than the other. And then finally, we learned that parsing offset-aware strings results in UTC time zone, and it's up to you to set the time zone that you know that your data corresponds to. Now, please go out and convert some time zones. I do offer some polars training. Get in contact with me or with my employer, Quansight Labs, and we can figure something out. Thanks for your attention, and let's open up the floor to some questions. I can see some clapping emojis and some heart emojis. Thank you, everybody, for your support. You're absolutely wonderful. So Ian asks, any gotchas to be aware for users of pandas with time zone handling? So pandas, the time zones are technically incorrect after 2038 because it needs to update how it's doing them. So if you're using data that's after 2038, then for now, I'd suggest using polars and not using pandas. otherwise use whichever you're already using in your application or whichever one you're more familiar with. Other than that, anything... other than that, I'm not aware of any gotchas. They should work quite similarly. So Lucas asks, what datetime features does Polars not yet offer? So one that comes to mind is interpolating values based on a column of datetimes. In pandas, if your datetimes are the index, you can easily interpolate with, I think it's like series.interpolate method equals index. Polars doesn't yet support that, but somebody did write on the Discord today that they were planning to work on that. So hopefully we'll have this relatively soon. And that leads me on to the topic of the Discord. The Polars Discord is really active and lots of fun. So if you're not in it already, I'd suggest you head on over to the Polars README and join the Discord and say hello there. Ian says, on note for others, if you use toDateTime in Polars, you get nicer parser error messages, more useful than if you do the same in pandas. Okay, well, that's probably a damning indictment on myself because I've done a lot of the work in toDateTime in pandas. So thanks, Ian. I'll take this as a to-do for what I should, do in pandas. Thanks. Okay, Sheng asks, why Polars for handling time zones? What's stopping Sheng, I think your question is about why is Polars correct after 2038, but pandas isn't. So pandas for time zones uses PyTZ, whereas Polars for time zones is deferring everything to a Rust library called ChronoTZ, and there's a limitation in PyTZ regarding that. But there is an issue about switching from PyTZ to zone info in pandas. It's just, lots of legacy code to update, lots of things to do, and relatively little funding. So that's just the reality of open source. Ian says, no critique, just an observation. Yes, none taken. I didn't mean that in the sense of I'm offended, more like thanks for bringing that up. This is a to-do. Okay, Moon, would you mention again when one would use convert time zone versus replace time zone? So convert time zone, you've got some local date time and you want to know what local date time that would be somewhere else. Whereas replace time zone is more like you've got some local date time and you just want to make that same local date time, but in a different place. If you look them up in the docs, there's examples of both. I think most Polars doc strings have examples. Luca, could you elaborate more on the example of sales? Why should I not run any logic in UTC? So I'd suggest storing your date times in UTC, but once you need to do logic that is above the hourly level, so anything you're doing at the daily level, then the boundaries between dates changes according to your time zone. So if you're in a time zone which is exactly the same as UTC and does not observe daylight savings time, then by all means do all your logic in UTC. But if you observe daylight savings time, like we do in UK, Europe, United States, lots of places, then doing everything in UTC means that sometimes your date boundaries are going to be like from 11 p.m. the previous day to 11 p.m. on this day. That might not be what you want. So storage UTC is good, logic to local. Yeah, that's right. Cool, I think we might be at time. I can't remember if it was 30 minutes including questions.